Hi there, in this video we'll be looking into a problem called k closest points to origin. Let's jump into the problem statement. So given an array of points where points I represent x and y coordinate of the point on the xy plane and an integer k, return the k closest points to the origin. So the distance between 2 points on the xy plane is the Euclidean distance, the regular formula, and you may return the answer in any order. The answer is guaranteed to be unique except for the order that it is in. Okay, so we are given a set of points. In that set of points we have to find out the first k closest points from the origin, right? If we take these two, right, so let's say they have asked only 1 point to give back, k is 1, so we have to find out whichever is the nearest between these two and give it back, right? In the given set of points we have to return the top closest points, the top k closest points to the origin. Okay, and the distance, it would be the regular formula, and the order of the points doesn't matter, and there will be only unique solution in the given set of points. And if you look at the examples given to us, we have given 1, 3 and minus 2, 2, and it is asked we have to return only 1 point. K equal to 1 means k specifies how many points we have to return back. So in this case it is asking for only 1. We will find what is the topmost closest and return it back. So yeah, and if you see square root of 10, square root of 8, obviously square root of 8 is smaller, so it will be closer, and that's why minus 2, 2 is the closer point to the origin. And if they have asked k equal to 2 here, we will return both of them, right? There are 2 points and they have asked the top 2 closest, so we will return both of them. In the other example, if you see, k is given as 2, and in this case these 2 points are the closest to the origin, that's why we have considered these 2. And the constraints given to us are like k value points comma length, k is less than points comma length, or k can be equal also, and the maximum points is 10 to the power of 4. Also x and y coordinates can be minus 10 to the power of 4 to 10 to the power of 4. By this time you would have roughly guessed the approach we will be taking. It is straightforward. So we are given a set of points, let's say p1, p2, all those, right, all those, and we have to find in this set, we have to find k number of points which are closest to the origin. So simply we can find the distance between this point and this point origin, right? Distance between p1 comma 0 0, let it is d1, d2, d3, d4. So we have to, from this list we have to get the top for the top k, not for the top k closest points, rather than top, the least k closest points, right? One way you can think of is you can have a hash map where you maintain the distance with the point, x and y coordinates. Then once you have done fill the hash map, then again you can sort it based on the key, which is the distance, then you can return the top k. That is one approach, which is fine, but it's just that it takes more space complexity, right? And again we have to traverse through the hash map once more to find to sort it and get the top 4, right? But if you observe, there is one more functionality available in every programming language. In Java we have something called priority queue. So every programming language, it has its own priority queue, but in Java we have something called a readily available collection given to us as a priority queue. It is simple. Whenever we insert it, based on the comparator we defined on that priority queue, it sorts the elements. It keeps it in the hash map. You are inserting, then again you are sorting, right? But in priority queue, what happens is, based on the conditions, when you are defining the collection itself, you define what is the comparator. Comparator is while inserting what is the sort order it has to consider. Okay, So based on the comparator, it inserts the element, it retains the order of it, and at last we can find out we can iterate back on it and get the elements. And one beautiful thing is, as we know k, we can maintain only k number of elements in our priority queue. In hash map we have to maintain everything, right? But in priority queue we don't have to maintain everything, because once we reach the limit, we will remove the farthest one from the priority queue, right? Okay, so for this we will be using a data structure called priority queue. If you are not aware how this priority, it's just a queue based on a priority condition defined using a comparator. Okay, if you are not aware of this data structure, I will advise go back and look into the internal implementation. As part of this video, we are not going to do that. We take that priority queue as a data structure available to us. On top of it, we apply this logic of inserting the elements. Then when we define the comparator. So when we insert, it inserts in the fashion which we want. Then we get back the elements, right? One thing with priority queue is, when you define the comparator, let's say d1, let's consider these values 4, 10, 3, 2. Let's say k is given as 2 for us, right? So priority queue, my priority queue, I initially start inserting 4. Good. When I insert 10, I want it to go on top, because when this reaches the limit, which is k, I want to take this out, which is at maximum distance. So when we are defining that comparator, we have to define it in reverse manner, because we have to have it in the descending order rather than the ascending order, right? So when we define a comparator, we generally do this, right? A and B are two elements which are getting in, and we define the condition here, A minus B, right? Whichever is like it, when it is inserting B, it compares with every existing element and puts it in the ascending order, like 4, 10. When 3 comes, it will put it here. When 12 comes, it will put it here. But what we want it in reverse way, like this, because when we want to evict the elements, we want to evict, it will evict from the top. That's why we want to keep the top elements. But when we are getting it back, we want to, the order doesn't matter, right? The order doesn't matter. So we can we would have only 3 and 4 with us, right? We will return back 3 and 4. I mean the distance, the associated points for distance 3 and distance 4. It's just that when we are defining the comparator condition, we have to reverse it. When we do this, what happens is, this will become, still it maintains at ascending order, but this distance will become -4, this will become -10, this will become -2. I mean, when it is adding, it compares with the existing value with this one, right? When it gets the negative value, it considers that it is to be inserted on the top, because it is lesser than the existing element. Okay, so let's code this. So initially we definitely want a result result. For this we need a new int array of size k, because we will have k elements. Definitely we want only k elements, and we need a priority queue. We need a priority queue, right, which will hold the xy coordinates, which is an array of size 2, and it is our queue is equal to new priority queue. Okay, so post that we will start iterating on the points. We get each point from the points, right? Then initially what we do is we insert it And one more point is we have to define the constructor, right? We have to define the comparator. So for this we will define a method called square distance. If you observe, I don't want to calculate the root because anyways here 10 and 8, if 8 is greater, obviously if 8 is smaller, that will be the shortest distance. So I'll have a, here I have to do b minus a, I have to reverse that, so that the value, the comparison will come negative and it will go on the top. So I need to define this method, public void square distance, this would be an int array called point, right? And what I want is point 0 star point 0 plus, it is distance with origin, right? So x minus 0, which is x square, right? Point 0 is x, so x into x, x square. Similarly y square, which is 0.1 into 0.1, right? I have to actually return this and I'll have to mark it as int. Okay, now for q I want to push it. So for this we have something called offer method, which just when it inserts it, it considers that comparator and insert the element. So if after inserting, okay, if the queue size is greater than k, which means we have bypassed the capacity, that's when we will say pull from it. So it will pull from the top, right? So now we have inserted the elements into the we cannot return back the queue, so we have to iterate it, I equal to k. So I am just maintaining a counter and I am maintaining a while loop. So while q is not empty, so I have put in the negation, right? I am going to insert it into my result. It is starting from I, right? So the order doesn't matter here. So but here, in case if you want to return the order in any way, so we can do it in either ways, that doesn't matter. So but I'll put it in the order itself, I comma 1, sorry, this would be 0 will be my I, 0 would be my q 0, right? Or I can directly pull from it. Pull will give me that particular, and it will directly insert it, right? It will directly insert into that array. Now I return my result. Okay, and we have to, of course, decrement this. So we have to start from decrementing we have to decrement, and k would be 2, right? Then the index would be 1 and 0, right? So that's why we decrement it and then assign it to I. Let's run this. Okay, there is, it says cannot find symbol method pull. Okay, I think it is not pull, it is poll. Poll is the method to get the element. So let's run this now. Okay, the test cases are passed. Let's submit this. Okay, the solution got accepted, and runtime we are better than 49%, and memory usage is better than 89%. Okay, so I hope the solution makes sense to you. Thanks for watching. Let's meet in another video.